Hello everyone, how are you? I am Akrash, your teacher here, and I will teach you different questions and their answers. So I welcome you on classtheta.com. So our today's question is: write a simple C or C++ program to measure estimate the overhead of system calls versus procedure function calls. We will compare the overhead of the standard Unix Linux system call getpid, which simply return the pid of the calling process, with the call to a dummy function which performs a simple and trivial operation and returns. It seems appropriate to compare the dummy function to the getpid system call, since the both don't perform any work other than returning a single value. Use the Unix Linux timing function clock get time to measure the overhead of system calls and procedure calls. It offers high resolution timing measurements. The basic idea is to measure the total time of many repeated system calls and the dummy function calls. The following code show how you can measure the execution time. Include into sys over types h, include into unistd h, include time h, include stdioh, define no iterations 1 0 0 0 0 0 0, define nanoseconds per second 1 0 0 0 0 0 0 0 0 0, type struct time spec int tummy func into int x, int y equal to 10, y equal to y plus x, return y, return the number of nanoseconds between two timestamps, unsigned long diff time spec start, time spec end, time spec temp if end dot tv and sec start tv and sec less than 0, temp dot tv sec is equal to end dot tv sec start tv sec 1 temp v and sec is equal to nanoseconds per second plus end tv and sec start tv and sec else temp dot tv sec and tv sec start tv sec temp tv and sec and tv and sec start tv and sec, return temp tv sec nanoseconds per second plus temp tv sec and sec, int main temp spec time 1 time 2 double average syscall average proc call int a clock get time clock monotonic and time 1 for int I equal to 0, I less than no iteration I plus plus a, get feed clock get time clock monotonic time 2 average syscall is equal to double diff time 1 time 2 double no iteration, print average syscall time percentage if n average syscall clock get time clock monotonic time 1 for int I equal to 0, I less than no iteration I plus plus a dummy func 20 clock get time clock monotonic time 2 average pro call double diff time 1 time 2 double no iterations, print average procedure call time percentage if n average pro call return 0. You can start with the above program and modify it to print the following information. 1 point, print the average system call execution time, i.e. the total time divided by 1 0 0 0 0 0 0 repeated execution of getpid. The above program already does that. 1 point, print the average dummy function call execution time, the total time divided by 1 0 0 0 0 0 0 repeat execution of the dummy function. The above program already does that. 3rd point, rather than measure the total time for 1 0 0 0 0 0 0 execution, measure every system call and function call individually and store the individual measurements in two arrays, one for system calls and 1 for function calls. Repeat those measurements a reasonable number of time. Example 10000 iterations. Third points. For the individual measurement, calculate the mean and standard deviation and print them. Run the program on a Linux server. Write down the value reported by your program. 2 points. Discuss your result. 2 points. Intuitively, the mean value calculated from measuring many individual calls versus a single measurement of many repeated calls should be similar. In practice, they differ quite a bit. Try to explain why that happens, and answer of the question is C. Include sys types. H. Include Unisted. H. Include time. H. Include stdioh. Include math. H. Define no iteration. 10,000. Change the number of iteration for better accuracy. Define nanoseconds per second. 1 0 0 0 0 0 0 0 0 0 0 tab struct time spec int dummy func int x int y is equal to 10 y equal to y plus x. Return y. Return the number of nanosecond between two time stamps unsigned long. Diff time spec start time spec end time spec temp if end tv end sec start tv end sec less than 0 temp tv sec end tv sec start tv sec minus 1 temp tv end sec nanoseconds per second plus end tv end sec start tv end sec else temp tv sec end tv sec minus start tv sec temp tv end sec is equal to end tv end sec minus start tv end sec. Return temp v sec nanoseconds per second plus temp tv end sec int main time spec time 1 time 2 double total syscall is equal to 0 total procall is equal to 0 double average syscall average procall double syscall times no iterations double procall time no iterations int a for int j is equal to 0 j less than no iterations j plus plus clock get time clock monotonic time and time 1 is equal to getpid clock get time clock monotonic and time 2 syscall times after diff time 1 time 2 total syscall plus is equal to syscall times j clock get time clock monotonic time and time 1 is equal to dummy func 20 clock get time clock monotonic and time 2 procall times j diff time 1 time 2 total procall plus is equal to procall times average syscall is total syscall no iterations average procall total procall no iterations printf average syscall time percentage if nanoseconds and is average syscall print average procedure call time percentage if nanoseconds and average procall. Calculate mean and standard deviation for system calls. Double mean syscall is equal to 0 std dev syscall is equal to 0 for int I is equal to 0 I less than no iteration I plus plus mean syscall plus is equal to syscall times mean syscall is equal to no iterations for int I is equal to 0 no iteration std dev syscall plus is equal to POW syscall times mean syscall 2 std dev syscall sqrt state dev syscall no iteration. Calculate mean and standard deviation for procedures calls. Double mean procall is equal to 0 std dev procall is equal to 0 for int I is equal to 0 I less than no iteration plus 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 mean procall plus I equal to procall times mean procall is equal to no iteration for int I is equal to 0 less than no iteration I plus plus std dev procall plus is equal to power procall times minus mean procalls 2 std dev procalls is equal to sqrt std dev procalls no iteration printf mean syscall times percentage if nanosecond and mean syscall printf standard deviation of syscall time if nanoseconds and std dev syscall printf mean procedure call time percentage if nanosecond and mean procall printf standard deviation of procedure call time percentage if nanosecond and std dev procall return 0 value reported by the program on a Linux server. Average syscall time 11.971900 nanoseconds. Average procedure call time 0.106400 nanoseconds. Mean syscall time 11.971900 nanoseconds. Standard deviation of syscall time 0.000057 nanoseconds. Mean procedure call time 0.106400 nanoseconds. Standard deviation of procedure call time 0.00001 nanosecond. Discussion: the results show that the average execution time for a system call getpid is significantly higher than that of a simple procedure call. This is expected because a system call involves transitioning from user mode to kernel mode, which incurs additional overhead. Difference between mean value and individual measurements. The mean value calculated from measuring many individual calls versus a single measurement of many repeated calls differs due to variation in execution times for individual calls. The mean value is an average of all individual calls and it accounts for both fast and slow execution. However, a single measurement of many repeated calls may mask the variance in execution times, leading to differences in the reported mean values. Thank you for watching the video. If you have any question related to this video, please post a comment below. If you have any question in your mind, you can also post on the website and I will be answering you in the next video. Thank you for engaging with us. Until next video, bye bye.